Hello, so today we are going to try to solve this problem called minimum size subarray. Subarray sum. So the problem says we have an array of positive integers that are numbers, and so we have numbers and then we have a value target, and we want to return the min length of a contiguous subarray. Of subarray of which the sum, such that the sum is greater or equal than target, greater or equal to target. Okay, sum is greater or equal to target. There is no such subarray. We should return 0. Okay, if it doesn't exist, we just return 0. So we get an array, we get a target value, and we're going to return the minimum length of a contiguous subarray that has a sum that is bigger or equal to target. Okay, and here for target 7 we can find 4 and 3, which give us the minimum length. And they are saying if we figured out an open solution, we want to try to do one that is open log n. So saying one that involves open log n would mean maybe sorting, but then we can't sort because we want a contiguous subarray. So we definitely can't sort directly. Like we can't sort the array first, right? Now let's see. So with something like this, let's take this example and see if we can come up with something. So with target value equal to 7, and this is the array. Okay, we want to try to find contiguous sum. Can I do any brute force solution first? Well, brute force solution, just basically try all possible intervals, right? And get their sum, and then and filter out those with sum less than target, then pick the min, right? Now looking at this would be, it's more n squared, so we don't want that. Can we do something better? Maybe we can do 2 pointers or something like that. So if we have this and have a pointer here, we find that the sum is, so once the sum is bigger than target, so it's only positive integers, right? So once the sum is bigger than target, it will only increases, right? So maybe we can have 2 pointers, right? And then just have current sum. So we have here maybe left, right? And we find that the current sum is 7, right? Is 5 here. So basically when current sum is less than target, well, in that case, increase r, right? And so we increase r, we get sum is 6, we increase r again, we get the sum is 8, right? And so 8 is bigger than target, else when its current sum is bigger or equal to target, well, we need to update. So min so far, we can have min so far, right? So update min so far. If a better one, basically if current sum is better, and then, so at this point min so far would be bigger or equal to target, so would be 8. And so here, else if, what we do is So here, let's do this a little bit. If increase R, as if it's bigger, right? We need to say min so far is going to be equal to the min of min so far and current sum, right? And then we need to do advanced L, right? So we do L plus 1. L plus 1. So we advance L like this. Then R becomes like this. And now when we do L plus 1, so when we do this, right, current sum is going to be plus with the array at R. And then here, if we decrease this, then current sum, we would need to subtract array at L. And at this point, we would have current sum would be -2, right? So we'd go back to 6. And if we do that, then it's smaller now. So we need to increase R, add 4. Now it's 10. It's bigger. We didn't find it's not better than 8, right? Because we are looking for the minimum. And so we 8 is bigger still though, right? So we are here, and so our min so far stays the same. We advance L, so now our L is here at 3, right? And so we subtract 3, we have 7, so it's in the minimum length. Okay, so actually what we want is the minimum length, not the minimum sum. So min length so far. So earlier on when we had 5, 6, 7, 8, the length was 5, 6, right? 7, 8, so the length was 4, right? Basically this would be R minus L plus 1, right? We need to do we need to do this. And now once we have this 3, 4, that's 7, the length is 3, that's better, so we do 3. And then we already did hang on, I think this is the next iteration when its current sum is 7. So here current sum, so once we do this, we go back again. 7 is bigger or equal. Now we have that. And then we subtract again, right? So this would be like this, okay? And now we have 4 and 2, which is 6. So now the current sum is 6. That's smaller. We go here, we increase R, and we increase our sum. So now our sum is plus 3. So 7, 8, 9. And now this is bigger. We enter here. Is this length bigger? This length is 3. It's not better. We already, so the length is 3 here. We already actually updated with 3, but that's fine. Now we do 4, and then we add increase L, right? And we now have 4 and 3, and 4 and 3, the current sum is 7. We go again back here. Back here we have it's bigger or equal, so 7 again. And so we update this, now it's 2, and current sum now is 7. This is good. Cool. And then we end once we reach the end. So LR come at the end, and we are done, right? Yeah, so I think this should work. So let's do it. Let's do a 2 pointers here technique. So we'll start out with LR both at the same position, right? And then here, while they didn't meet, we say we do this basically. We need the min length so far. Let's just call it min length, and then we need current sum. These needs to be defined outside, and then we need yeah, I think these are the 2 we need. So min length so far, we need to start out with infinities, and then we need current sum, which starts out as 0, right? And then we start doing this. Now, if current sum is less than target, we need to increase r, so that would mean r plus 1. We increase the current sum with the value there. We need array here, and else, this needs to be, can be just else. We do min length is going to be min length, and then we increase L, and then we decrease by the element at position L, and then here we can just return the min length, and we can say min length if different than, let's call this if, just to simplify here, and is different than min if else 0. Okay. That's strange. Oh, okay, yeah. Initially it's not less, so that's why. Yeah, I think we can just do have it like at the end essentially. Okay, so current sum actually, let's do it array 0. Okay, here and r, let me do n as well. So this would be length of the array, and we need r to be less than n, otherwise we can only shrink. Okay, then here target is 11. Yeah, I think there would be a problem. Yeah, that's what I expected. The bonds here are not right. The way I'm updating these are not right. So let's actually start with 0. Let's keep this. Let's initially do this, right? Every time. And let's do this first. Yep, so that we can subtract the element. And here should be enough. Actually, we don't need this. I think we need this. Okay. Okay, so it seems like something here is messed up. Okay, let's take these examples, put them here, and try to fix the problem for the second one. Okay, so because these are equal, the target is 4, right? So actually 0, 1, 2 both should work, except the target. So when I return the length, I'm saying 2, and actually 1 is enough, right? So I don't, seems like there is a problem with one range when left and right have only difference of 1. Let's print. So we start out with 0, 1, we expand to 0 and 2. So 0 and 1, the sum is 5, right? The sum is 5. The problem is that current sum is 0 at this point, right? Should start out as R0, right? Then we'll find that it's smaller, and so we would add target, right? Yep. Now if it's, what happens if it's this? Okay, seems like it didn't work for this case. Let's see why. So it's only ones, 3 here, 6, 7, 8. So when there is no solution, I should return 0. But I'm returning 2 for some reason. That should not happen, right? Else with, wow, it happened a lot. Okay, so this is because I do it when r is equal to less than n. Okay, so yeah, if current sum is bigger or equal to target, then we do this. Otherwise, it's not bigger, right? And we already reached n, right? So here, it's smaller, right? So here, basically, current sum is less than target. And left is, and r is already reached n, right? What this would mean is that we should just break, right? There is no, yeah. Okay. Now let's try again with all of them. Okay, the first case doesn't work anymore. Let's see. So it looks like the first case is a little bit more. Let's identify which case is wrong. identify when we get min length equal to 3 here. So that should be fine, but I never reach the min case where 4 and 3 are together, which is probably because I break when we reach n and I don't continue. Well, that should not have happened, right? Because, so here, let's do current sum as well. Current sum is equal to this. So current sum is 7, right? Okay, so this is definitely because we are at 4 and 0, 1, 2, 3, 4, 4, 5, 6. 6 from R. Okay, so need to do. It's because of this one here is too much. Okay, cool. Let's comment this out. So we're looking for the min length. Let's take one that is just one size. So let's say 5 and 5. So it should return 1 here. Why? So length can be 1. Okay, target needs to be first. So 5. Let's see. Okay. Now what about if we had like 10 and we have just 3? So it should be 0. Okay, so that works. Let's try to submit. Okay, so that passes. Cool. Yeah, so just 2 pointers seem to work here. Yeah, cool. Thanks for watching and see you on the next one.